Welcome to the fifth lecture in 11th week. We are studying Poisson process, and here is a small recap of what we have studied till now. We know that to model a Poisson process, the number of arrivals, it is used to model number of arrivals in a finite interval. The width of the interval can be variable, but the rate of arrival is fixed. Rate of arrival means number of arrivals per unit time. They are fixed. However, we can model it using finite intervals of variable length. Today we'll talk about the PMF that governs Poisson process. Total arrivals in a given time period, in a given time interval, small t would be lambda multiplied by t, where lambda is the rate of arrival. Arrivals per unit time. Total number of arrivals in a given interval of time would be the rate of arrival times the length of the interval. This is obvious. Lambda times t. We divide it in m slots, where m is very large. It approaches infinity. This means the width of each slot is very small. How can we write the number of arrivals in one slot? The total number of arrivals with this arrival rate in this whole span is lambda times t. If we divide it in m slots, where the number m is very large, this means the width of each slot is very small, but the expected number of arrivals in one slot is lambda t over m, where m is the number of slots in which we have divided this whole span. This gives us this number which approaches zero, because m approaches infinity, therefore, and the m is in denominator here, therefore this ratio approaches zero. Now it can be thought of as a Bernoulli process, because in one slot we can expect only one arrival. That is the basic concept behind Bernoulli process, because we already know that in a Bernoulli process, in one given time slot, the probability of having one arrival is b and having no arrival is 1 minus b. There is no such thing that there will be two arrivals or three arrivals in a Bernoulli process. We already know. So now if we want to compute the PMF of having k process in this time t, where this lambda t over m is the probability of success in a given slot. We have these m slots, and out of which we want to find out the probability of having k arrivals. In this whole span t, which is divided in m slots, we are going to compute the probability of having k arrivals. So what should we apply? Binomial theorem. Binomial theorem. Binomial distribution, sorry. So binomial distribution, the expression for binomial distribution will help us, because we want to find out k arrivals in t time. So that would be t combination k, the probability of success, k, 1 minus probability of success to the t minus k. This t, k, where the probability of success is lambda t over m, where m approaches infinity, to the k 1 minus lambda t over m to the power t minus k. So this requires a little algebraic effort, and after we solve this, we reach to a value having the probability of having k arrivals in t time is e to the minus lambda t to the k over k factorial. This is the PMF that governs this Poisson process with parameter lambda and for time interval, and we want to find out the number of arrivals in a given time interval t. So we can have any value of t put into these expressions with given lambda to find the probability of arrivals. An example, we'll keep the example that we solved in last lecture, where at my residence the number of fluctuations in AC voltage is 3 per minute. So this is lambda, 3 fluctuations in a minute. This means, and we want to find out the probability of maybe 5 fluctuations in 1 minute. Time t is equal to 1. So that would be simple, e to the minus lambda 3 times 1, lambda t 3 times 1 is 3, to the k, you want to find out 5 fluctuations over 5 factorial. But what if want to find out the probability of 10 fluctuations in 3 minutes? What is the probability of having 10 fluctuations in 3 minutes? So here we have t is equal to 3, x is equal to lambda, x is equal to 10, t is equal to 3, and lambda is 3. So we'll put all these in the PMF, in the expression for PMF, minus lambda 3 times t, 3 times 3 to the k, 10 over 10 factorial. So we can compute answers for this, and we can compute the probability of having any number of fluctuations in any given interval of time, but lambda, the rate of arrival of these fluctuations, remains the same throughout the process. We will keep on studying Poisson process in our upcoming lecture 2. Thank you.